Good afternoon, everyone. So I'm Noémie Läng from the University of Nottingham, and I'm going to present my research on improving biodiversity in the built environment, investigating facade solution and the impact on local biodiversity. So we all understand the link between the built environment and climate change, but that link with biodiversity, there is way less research and less information. But there is a new regulation that's going to be applied in 2 months, where all planning permission will need to deliver at least a 10% biodiversity net gain to be constructed. So I wanted to enter that new policy and focus on biodiversity friendly facade solution for urban areas, so for big cities. So the main question is, how does green walls and biodiversity bricks impact local biodiversity and the building's envelope? So the methodology was, after doing the background research on those two solutions and many topics around it, I did an assessment through interviews to understand the barriers and opportunity on the application. That helped to do then the assessment of biodiversity net gain. So using the DIFRA biodiversity metric, which is the metric that is used for the new regulations. I then did through IES environmental performance evaluation with daylighting analysis and thermal comfort analysis. Everything helped to suggest recommendations for plannings and for architects. So a case study was chosen in Nottinghamshire, which was the base case of typologies, where green walls and biodiversity bricks were added on. The project had a biodiversity net gain calculation report, which helped me fill in the biodiversity metric. So just to give some definition, so biodiversity bricks are just bricks that can replace red typical bricks in a building and have a different texture on one of the aspect of the brick, and that allows plant species and insects to either grow on the surface or find shelter and breed in. So first I did the interviews and the narrative analysis around the results of 17 open questions of many aspects, but I will just speak about the main insights. So biodiversity bricks are the most useful if they are placed near like an existing habitats. And that is also the same for green wall, that we make the most impact in like ecological impact. Also, the abundance and the variety of plant species used on green walls is like one of the key factors. And one thing that I couldn't focus on in the biodiversity metric, because it's a limitation of the metric, is the orientation of the green walls actually have a big impact on the efficacy of it, but also on the chosen species grown on it. So that was one of the limitations of the research. I then did the assessment of the biodiversity net gain. So of course, the more green wall used, or the more biodiversity bricks made the biggest impact in the local biodiversity. We can see that, for example, one house with 4 green walls made around 0.5% net gain, which means that 20 houses would fill in the 10% biodiversity net gain target. That's for the typical detached home. And then to give just another example, biodiversity bricks, which are way smaller batch of new biodiversity added to a wall, gives very small results. But biodiversity bricks on 4 walls equals around 50% of the project homes to be sufficient to achieve the 10% biodiversity net gain requirement. I then did the environmental performance evaluation. So biodiversity bricks were assessed to have no relevant impact on the overall building and road performance because of the very small size of them and because there is no material density changes or very no created shading. But green walls, on the other hand, they do improve the summer overheating risk. For example, just one green wall added on the west or the south grand facade showed really good results. So the baseline had an overheating risk of 10.3% of the percentage of time in the outside of the comfort zone, so outside of 25 degrees. But it went with one green wall added to the west facade to 9.10. Green wall also obstructed natural daylight, resulting in lower daylight factor and useful daylight indicator. For example, south-facing green walls resulted in around 60% reduction in lux compared to the baseline UDI. So the impact of all the different iteration or level of strategies are not aligned between each important decision factor. So the biodiversity performance, the thermal performance, and the daylight performance. So for biodiversity bricks, it is recommended to place biodiversity bricks near the ground, and for B bricks, which was taken in the interviews, around 1 meter from the ground, near a facade or an existing green area. And different type of bricks are better in different orientation, and different texture of bricks grows different mosses or animals or insects. And for the green walls, it is recommended on the west and on the south orientation. And so the study has shown feasibility and a lot of ecological impact that proves that it is a very useful strategies and shows that it's very important to convince developers and architects to use the solutions. Thank you.
Thank you very much. Any question?
Hi, thank you very much for a very interesting topic. Which climate file did you consider for your overheating analysis? Did you consider current weather file or future?
No, current.
Current one.
Yeah.
Okay. So you haven't considered climate change and what happens not yet.
Not yet. I would have loved to.
And the other thing regarding, of course, you say that there is significant improvement in overheating, but actually the percentage is very small improvement, no? 0.3% from 10.3 to 10 or 9.1.
Yeah.
So is an improvement, but it's small, but it's still there, and it could be obviously.
But that's only for one green wall.
For one.
Yes.
On one facade, you mean?
One facade.
Okay.
Yes.
And you haven't done the cumulative?
Sorry, what?
Have you considered the cumulative effect of all the facades?
Yes, the impact is
higher,
but I mean, didn't have the time to present everything, but on the paper.
I presented the one that is higher, so we can see the significance.
It's just the feasibility of using only one green wall makes more sense in terms of cost and orientation as well. And the plant of view, like the use of the plants we had on, it's more easy to go on the south and west facade. So the north doesn't make that much sense to use. Okay. So I took into account mostly one.
Okay. Yeah. And also, did you consider the impact on the winter performance on the heating?
Yes, I did. The impact was very low, and not that didn't make sense to focus on that because it was really low.
Yeah. And for the daylighting, it's really interesting that you say. I guess you are assuming that the vegetation will grow in a way that obstructs, no?
Yeah,
but obviously if there is a design that is done on purpose, for example, the reveal of the window can be put forward so that then the growth of the vegetation and the place where you put the bricks will be recessed and there is no effect on the daylight.
Yes. So, for the daylight analysis, the result shown, like the reduction is big with, like, for example, the 4 green wall, but it still fills the benchmark of the Lux number or the day life factor percentage. So for every room, it was still filling in the benchmarks.
Okay, thank you. Very good.
I just would like to ask you something. I know that the biodiversity net gain requires a minimum of 10%, but your case study was a low density area. What would be your gut feeling in terms of a city center? How easy is it to achieve that 10% or even go beyond? Because I know of a couple of local authorities that are looking on their local plans to have a higher requirement in terms of BNG.
Yes, that makes total sense. So that's the reason why I wanted to focus on green walls and biodiversity bricks, because it can be added here if it's well placed with like green spaces around it. So I'm using a case study in Nottinghamshire, which has a lot of space, but every solutions and every numbers will be the same if it's in an urban area.
Be reproduced in the
Yes,
city.
exactly. Yes.
Thank you.
Thank you.